Bismillahirrahmanirrahim. Solution of Maxwell field equations. So in this video we are going to discuss solution of the Maxwell equations. Show that the solution to Maxwell equations where rho is a function of x, y, z and c is the velocity of light, which is a constant, are given by, so these E and H, these two function that satisfy these two equations satisfy the Maxwell equations. So solution of the Maxwell equation, so function E and H satisfy these two equations. So these type of equation will be solution of the Maxwell equation if condition 1, 2 and 3 satisfied. So here we will show that E and H, E is the electric field and H is the magnetic field. So if the electric field of this type and magnetic field of this type, where A is vector potential and phi is scalar potential, E of this type is some combination and of derivative of the phi and phi scalar potential and a vector potential, and the curl of A is the magnetic field, then they will satisfy the Maxwell equations under these conditions. So let's start from the equation divergence of H. So the divergence of H mean the divergence of the curl of A in this equation. So we know that this is scalar triple product of three vector. If two are the same, then it is 0. So the first equation satisfied. Now check the divergence of E. So apply the divergence on this E on both sides. So the divergence of E is equal to minus the divergence of grade phi and minus C, okay, minus 1 over C, partial by partial t. So I interchange partial by partial t with the divergence with the nebula, divergence of A. So you see this value is given, this is over here. So that is, in fact, I will write from here, the value of this is 4 phi rho, that is the left hand side value, and this is nebula square minus nebula square minus nebula square phi. nebula square phi, and we will put the value of this from this equation. So that is minus 1 over c partial by partial t. So the divergence of A is equal to negative of 1 over c partial phi partial t. So you see 4 phi rho equal to minus nebula square phi, and this is now plus 1 over c square partial square phi partial t square. So if I multiply with the negative sign, minus, this will become plus and this will become negative. So this is exactly the condition 2. So if I take E to be this, this expression, then it satisfies condition number 2, and we have to satisfy, and this is in fact a source wave equation under source charge density rho. So that is the condition we have to satisfy it. So this E satisfy this condition. So the divergence of this give me this condition under using divergence of this value. Okay, so that's good. Now the divergence of both the equation, the divergence of this and this satisfy the conditions in Maxwell equations. Now, so we have satisfied these two equations under these conditions. So this solution satisfy Maxwell equation, these two equations under these conditions. Now we have to satisfy the other two equations. So let's start from the curl of E. So curl of E. So we have to take curl of E on both sides. So that is equal to minus curl of grade phi minus 1 over c partial by partial t curl of A. Okay. So by definition this is 0. Curl of divergence of phi is 0 because we have two vectors in same direction. And what is curl of A? That is curl of A is H. So I left with minus 1 over c partial by partial t of H, and that is the curl of E. So this E satisfies this equation. This E satisfies this equation. Okay. Now let's take curl of H. Curl of H here. This is the solution equation. So curl of H on the left side, and on the right side it will be curl of curl A. Now we will use the property. We studied this curl of curl some vector field. It is minus nebula square A and plus gradient of divergence of A. Okay. Now we have to use these conditions. We see that the value of nebula square A is 1 over c square 1 over c square partial square A partial t square. So I will put this value equal to that one. So this is equal to minus 1 over c square partial square A partial t square and plus gradient of the divergence of A. So the divergence of A I will put from here, that is minus 1 over c minus 1 over c okay, minus 1 over c partial by partial partial pi by partial t partial pi by partial t. So this is equal to minus 1 over c square partial square A partial t square, and we can interchange the operators. So the operator we interchange here, minus 1 over c partial by partial t in grade of phi, grade of phi. So I interchange partial by partial t with the grade. Now we will put the value of the grade phi from equation of E. From here we will put grade phi. So grade phi is in fact minus E minus 1 over c partial by partial A by partial t. So I'm starting from here again. Curl of H is equal to, so you see this is the first term, minus 1 over c square partial square A partial t square, and then I will put the value. So 1 over c partial by partial t and gradient of phi from here, so that is minus E minus 1 over c partial A partial t. So this is equal to minus 1 over c square minus 1 over c square partial square A partial t square, and we will get two terms from here. One will be plus 1 over c partial E partial T, and the second is plus 1 over C square partial square A partial T square. So this term will cancel with this one, and we will left with the Maxwell equation curl of H is equal to 1 over C partial E partial T. So the third equation under the given condition is also satisfied. This third equation of Maxwell, this one is satisfied, this is satisfied. This is satisfied, this is satisfied. So the solution of the Maxwell equation satisfy this condition, this sort of function under these conditions. That's all for the solution of the Maxwell equation. But you see, phi and A are general, so you have to take some particular function for these phi and A. Let's discuss one particular and very simple set of function phi and A. So let's take phi to be 0 and A to be A naught cos, okay, let me write a little bit down. A is equal to A naught cos kx minus omega t and let I take it in the j direction. Okay. So what is E in this case? E is equal to grad phi minus 1 over C partial A this is A naught, some constant, so it may be a vector. This is a constant, not a vector. Vector is in j direction, so partial by partial TA. So this is 0 because phi is 0, and I left with when I differentiate this with respect to t, so there will be omega with a negative sign, so this will become plus omega over C, this becomes sine kx minus omega t in j direction. So that is the E, that is the electric field. So what will be the magnetic field? The magnetic field satisfy this equation, that is curl of A. So curl of A mean I j k partial by partial x, partial by partial y, and partial by partial z, and a has one component which is along the y-axis, cos kx minus omega t, and the other is 0, so this determinant will give me magnetic field. That is the electric field function. And what is the magnetic field function? This is I direction, partial by partial y of 0 is 0, and partial by partial z of this function is 0. So that is overall 0. Then there is j. So j mean we have to differentiate this function with this and that with this. So that is overall again 0. And then there is k. So in k we have to differentiate this with respect to x and that with respect to y. So we have got something. With respect to x we have a naught. Okay, I left a naught here, so here is a naught. A naught is there. Okay, that is omega a naught over c. Now it is a naught sine so that mean negative sign is here, sine in k sine kx minus omega t. So h is this function, that is minus a naught k sine kx minus omega t, but the direction here is k, that is in k direction. So the electric field is in the I direction and the magnetic field is in the k direction. They are perpendicular to each other. That is okay. So the choice here, I make a choice phi 0, and we see that all the equation will be satisfied by these two functions, and that is your homework, to satisfy all the Maxwell equation by E and H. Okay, let's do one more question. A vector V is called a rotational if curl of V is 0. Find A, B, C so that V is irrotational. So find the curl of V. So here we see that V is irrotational if curl of V is 0. So take the curl of V. Curl of V is equal to determinant of this type x v. First component is x plus 2y and plus 2z, az, and the second component is bx minus 3y and minus z, and the third component is 4x plus c y and plus 2z, and we have to take this determinant. So in I, this will be upright over here, so I will get only c from here, and this will be upright over here, so I will get only minus 1 from here. So in j case, partial by partial z will be upright over here, so I will get only a from here, minus partial by partial x will be uprighted over here, so that is minus 4. And then k. Okay, so in the k, x will be upright over here, so that is b, and y will be partial by partial y will be upright over here, so that is minus 2, and this should be 0 vector if v is irrotational, so the curl will be 0. So if I put this 0 vector, then this implies the I component is 0, j component is 0, and k component is 0. So that implies c is 1, a is 4, our b is, and b is 2. So v is irrotational if ABC has have these values, so then v will become x plus 2y and a value is plus 4z, and that is in I direction. Then b value is 2, so 2x minus 3y minus z j, and 4x c value is 1, so that become y, and 2z, that is k. So this v is irrotational, mean its curl is 0. Now the second question is, show that v can be expressed as the gradient of a scalar function. Now the second question is, if v is irrotational, then it can be put this way: v should be equal to gradient of phi. Gradient of a scalar function. So the gradient of a scalar function is partial phi partial x I, partial phi partial y j, and partial phi partial z k. So comparing these, we have partial phi partial x is equal to x plus 2y plus 4z, and partial phi partial by partial y is equal to 2x minus 3y minus z, and partial by partial z is equal to 4x plus y plus 2z. So integrating with respect to x the first one, with respect to y the second one, and with respect to z the third one, we can find phi. So the first one will be integrated with respect to x. So phi is equal to x square by 2 plus 2xy and plus 4x and z and some function of y and z. Okay, now differentiate this with respect to y. So phi is equal to 2xy minus 3 by 2y square and yz and plus some function of g of x and z. And now this one with respect to z, integrating, so 4x and z plus yz and plus z square and plus some h function of x and y. So these three answers we have to find the unknown function f, g and h. So the answer phi is be collected in such a way. We have to search Pauli x function everywhere, Pauli x function. So that is only x by x square by 2. Then Pauli y function. Pauli y function is minus 3 by 2 y square. And Pauli z function, that is only the z square. Z square. Now a function of xy. You see we have a function of xy. So Pauli function of xy is 2xy. That is 2xy written over here and here. So we have to write that once. 2xy. A function of yz. Y and z. So y and z function written over here is so I think this will be plus. Why this is negative then? So there will be some mistake in the function. This is minus 3y. And this is minus z. Minus z. So this should be minus yz. So here y, so that is c C minus 1, so C is 1. So I'm writing over here one of them. This is YZ and YZ. So if I write both of them, they will cancel. YZ minus and YZ plus. So I think they will cancel out. Parallelly, YZ function cancel out. Okay, and parallelly ZX function, Z and X, that is 4x in Z and 4x in Z. So that is 4xz. So I'm writing YZ, one of them, either this is plus or minus. So this is the function phi whose grade is V. Okay, and this condition will satisfy grade phi. Now this function V is irrotational, and it can be represented in the grade phi conservative field. So a conservative field is irrotational and can be put in this way. You can find always a scalar function whose grade will be equal to the conservative field. Okay, thank you.